Alrighty. What's up, guys? Day 7 of prepping for this interview. It's starting to become a little bit too real that I actually will have to interview, which is kind of funny. And so I've realized that I kind of just am gonna fuck off on my assignments for the next 2 days. Because remember, the interview's on Thursday at 1 p.m. So I have all of tonight, and then tomorrow, and then really like Thursday morning, realistically, to prep for this. And that's it. So I think I'm just going to make the weekend worse for myself in regards to academics, and just literally do a bunch of problems, like not just the Pinterest tagged. My friend is also going to send me, because he has a leetcode premium, the Pinterest tagged list, and then I'm going to try to go through as many of those as I can. I don't know, I'm still like kind of just petrified at all the hards that I think I might just get fucked by. But I do want to cover the case of like we've been practicing a lot of like a lot of DP, a lot of backtracking, a lot of like technically like a top of sort stuff like that. Like technically hard problems, and obviously I still want to be practicing those, but I want to make sure that I still can like do 2-pointer and like do sliding window and do a stack problem and do a queue problem, especially like graph traversal problems, just to make sure like in the case where it actually goes like, hey, here's an easy question, here's a medium question, and then here's a hard question, and it's not like just hard questions. Who up leetcode? Bro, Ben, I'm literally going to do this for like, I think I'm going to do a 4-hour stream today. And I think I'm just going to only do it. So, I'm waiting for waiting for the Pinterest tagged ones, and then we're just going to run through them. Because, I don't know, why not? What is paging lab, really? I don't know. Okay. I also found this thing on Glassdoor. I was going through. How can I even move this thing over? I was going through these to try to find other problems, and most people are just like, it's a DSA or something like that. But this guy, the goat that he is, put a question. It seems really simple, but a question is a question from the source about a year ago. So, whatever. We'll do it. Okay. So it's, you're given a 2D integer array of size n by n, where each row contains exactly 3 distinct numbers. For each row, find the second most frequent number and return an array containing these numbers for all rows. Obviously, the easiest way of doing this is a counter object for each of them and then sort. But I don't really love that, because there's definitely some optimizations to be had such that like as soon as you hit some frequency, like for example this one, it's like we hit 3 ones in a row and we know like our call size is 5. We can early break. We don't need to keep going. And no sorting is needed for that either. So, and also the thing that it's, each row contains exactly 3 distinct numbers means we don't really have to do anything. It's just like, like we can do like scene 1, scene 2, scene 3, or something like that. We don't need some map. We don't need some counter because it's not like dynamic numbers. Let me disable the preview. Also lower my music. I'm kind of blasting my ears right now. Alright. So def, I guess I should, correct output would be an array that is the second most, I guess, how do we define ties? That's a question I would add for the interview, is how do you define ties for second most frequent in the case of like here is a 0 and a 3. So I'll just say the larger one if there's a tie, I guess. Do I like that? Yeah, I mean, what? It's arbitrary. In the case of a tie for the second most frequent, what would be the easier way to do it? Or, in the largest number. We'll just arbitrarily do that. It'll just be a constraint that I add. So then here would be 3, 4, like what would it be here? Because like technically 0 and 5 are, so then 5 would be ours. And this is actually invalid. Something like this maybe. And then we get 3. Yeah. So def segment some grid. I don't know. We can add a type signature where this is actually a list of its. So we'll have some res. Later we will return that res. And then a row and grid. I don't like hate just having these 3. Because it's always 3. So I'd add a comment here like, since we know there are only 3 distinct elements, subtract them. Alternatively, we could just do a quick dictionary. We just append. That's probably better. Just do like frequencies are that, and then since there's only 3 element thing, we can actually just use in. So then for num in, we could just make this a default dictive int. But at that point, why don't we just use a counter? I think it's fine. I guess the only reason I wouldn't just use a counter is because I want to do this early breaking shenanigans. I think a default just helps us there. So when can we guarantee that we've found the second most frequent, actually? I actually don't know if we can early break. We can definitely early break if we wanted to return the most. But the condition to early break is actually kind of harder for the second one. Because it would be like something along the lines of like if we've traversed, like if the difference between the second, no, it'd be hard. Because you'd have to look at the difference between the first, second, and third and guarantee that the number left that's like left in it is less than the number that's left in it is less than the absolute value difference of the frequencies between 1 and 2 and 2 and 3. And I just don't know if that's like a good performance gain. for the amount of work that this takes. Because each time we'd have to be checking the frequencies. I guess let's just do the naive solution first. C equals counter. A counter for a row. And then to define how we did it for ties is the only thing I'm thinking about now. Do we just want to sort by frequency? I think it's fine to sort by frequency. Because once again, you'd know always there's only 3 entries in this. So we're performing like an n log n thing, but our n is 3. So it's O of 1. So really it's just like O of the number of rows, which is fine. Because we guarantee have to traverse those. But building a counter is O of n, I think. Yeah, building a counter is O of n, like trivially. So it would be m times n. But I don't think you can really get away with that, or get away from it. I don't think there's a better way than O of m by n. Because like worst case will always be you have to like linearly scan up the linear. Yeah, I'm pretty convinced this is. I think that's right. So we would do something like it's actually very similar to the X sum we did yesterday, where it would be like frequencies equal sorted. You do code forces? Not often, no. Sorted C, the key equals a lambda item, item negative. I think this is the syntax. I did think that counter comes from collections. Get item not defined. I just kind of like disagree. So I'm just gonna keep going. Because then what we could do is res.append freaks 1 I think. Let's see. What did I call this freak array? Obviously, because I didn't call it. Lol. Int object is not subscriptable. But we're sorting C. And C is a counter from the row. I don't understand. Yeah, like that's fine. I think I literally did this yesterday. I'm literally just gonna like pull up the XM solution that I had. Oopsie dot items. Let's sort that out. Okay. How many SWE interviews have you given so far? I'm gonna take given as in like that I've done myself. I had one for IXL the other week, and then I had one for the part-time job that I have right now. And then last year I had one as well. So not many. That's the answer. 1122. That's wrong. Don't enjoy how wrong that is. So 2, 3, and then 3, 1. Oh, it's because this should be a 1. This should be a 0. Three, 4, 0, 0. By largest, we would do that. Oh, wait. Am I fucking this up like egregiously? Wait, so we want to descend? So like 2, 3, 0, 1, 3, 1. So no, why doesn't this work? I'm just confused. So 2, 3, 3, 1, 0, 1. That's fine. 1, 3, 4, 1, 3, 1. That's also fine. 5, 2. Then it should be 2, 1. Oh no, because 0. Okay, I think I just defined this wrong. Or no, I didn't. Ooh, there's actually an interesting wrinkle in this. In that it might not always be the one in that position. Because, like, if it's the first position, like, if it's a tie between 2 and 3, yeah. How do I want to do this then? What happens if I do this again? Bro, NPM install what? Right, because the tie then goes to there. Interesting. Why did I give myself this? It's probably better to practice it. I guess we can just walk it. It's actually just not that bad. Actually just don't need to do all this. I just don't know like a better way than just to define 3 variables. I mean, it's only 3 things, so you can literally just look at like, bro, fuck, this is frying me for no reason. I need some sort of caffeine or KV and C dot items. It's like horribly to code this thing, but so if the 0th position, so if the highest one, if its first position matches that of this is stupid. This is so stupid, so stupid. Literally just can just walk it. It's like the easiest logic thing, and I'm just frying. So for KV in this, like it's not F1 or oh, this actually just fried me. I feel like I'm literally just like misinterpreting this. I think I was actually just right. I'm like, I just asked ChatGPT. I'm like pretty sure I was just like right. I think this was just like the intended thing. Like that's I just asked ChatGPT because I was like, yeah, I just did the same thing I did. Okay. If you guys would like to see, I did literally the exact same thing. that solution. Okay. What do I want to go to now? Okay. Let's put you away. What we want to do here? What problems should I do? I had GPT give me some problems. So I guess we'll just run through some of these. I don't know. We're just gonna keep going. Word ladder. I don't know that off the top of my head. Allegedly, I've already done it. Transformation sequence from word begin word to word end word using a dictionary word list as a sequence of words. Begin word to S1 to S2 to SK, such that every adjacent pair of word differs by a single letter. Every SI for I to K as in word list. But the begin word does not need to be in word list. No, I'm definitely kind of there, Ben. But then it's like, I don't know. But you know, like the thing I'm like holding out for hope on is like that I'm just doing the fucking what's that? What's the anime where he like trains with ankle weights on? And it's like they just give me two, like a medium and two, or like two mediums and an easy. And it's like I do the whole thing in 10 minutes. Like what if it's that? What if it's that? It's probably gonna be 3 hearts. It's probably gonna be 3 hearts. I'm probably gonna get fucked. But like, you know, what can I do? I want money. I want a job. And as such, let's get the job. Okay, for this, honestly, like, what comes to mind is just backtrack. Like, all the valid words. Every adjacent pair of words differs by a single letter. But how do we even know that? Do we have to build a tree? Or a try? I don't know how to pronounce those. Because like hit goes to hot, how do we know what can go to what? If not a try. I think we do have to build a try. This just feels like a try. Let's look at the discussion. Because I'm just thinking, like, if you don't if you don't do a try, then your lookups are just gonna be terrible. And they're all 3 letters. So it's just not that hard. Also, I'm going to sit down. I told myself I would stand for most of this. No. I'm already fried. Because if we do a try, then what can we do? We can start with begin word. And then we can just BFS while keeping a visited array of every letter. Yeah. And then we kind of just keep going. I think that's fine. I think this is actually not that hard. How do you do the try not thing again, where it's like, I just want to make a mapping, but I know that since it's characters, I can just do a character array. I guess it's just like none, and then they'll have pointers. I don't know if I need the is end, but whatever. We're just building a try here, so we go over a root, and then for char in a word, if not cur dot children at C, then cur equals cur dot children equals try node at C. Cur equals cur dot children. Dot is end equals true. Def search. I don't think I need a starts with. I think it's fine to just have a search. So our search is going to be cur equals self.root. For seeding word, if not cur dot children, let's see, return false. Cur equals cur dot children, let's see, return true. Because wordless is guaranteed to be a length of 3, right? Or no. They're just guaranteed to be the same length. So they can be up to 10 length, but they're always the same length. Yeah, okay. So I think this is fine. Okay, so now we have some try. What we can do is T equals try. For a word and a word list, we can do T dot insert word. And then we can start our BFS. So our Q is equal to our deck, which will start just as begin word. We'll need to keep track of some visited set. Set beginward. So we visited that. And then we can do while q. Q node equals q dot top left. If so our node will actually need to be, our deck will need to be have some length attached with it as well. If so, this will actually be word and then path length, something like this. If word is equal to the end word, then we could just return our path length. And then else for I in range. Also just realized that we need to do, this is just wrong. End equals ord C minus ord of A. Okay. So for I in range 26. Do we really have to check? I guess this was bad on my part. But like, we have to kind of check every. Oh fuck! This might explode on me. Woohoo! I'm just saying it might explode because like we had to check like every arrangement of this, every arrangement of this, and every arrangement of that. But fuck it, I'm just gonna do it. They said all of them are the same length, so n equals length beginward. And range that. If temp word equals how do I want to do this? Like we're doing a lot of string operations too, which I don't love. Is there like a bro, fuck my life, I have to do this. Okay. How do you get string or get char from ASCII number? CHR. Because this is J plus that plus word. If temp word unvisited. I want to make word list a sec. Then we can add it to our queue. So then queue dot append temp word and path length plus 1. This seems bad, but alas, I kind of don't know what else to do. So if we never returned a path, then there's no such path. YOLO. List object has no as for children. Did I misspell visited? This is gonna time out. All right. What was the smart way to do this? What the frick? Oh, I never compare anything with. And this is wrong. I made a whole try and I didn't use the try. And t dot search word temp word. LOL. No, still gonna time out? Damn. Because this kind of does what I was thinking. This doesn't use a try. Wonder if I'm missing something simple. Interesting, so it does it both ways. Did anything use like a try? This just looks like exactly what I did. If transformed in wordset dot remove. Transformed. So like we've already gone there. I never add it to the visited. Maybe that'll help. Dude, okay. I'm like significantly slower for something. But actually like just don't think that I'm slower. Yeah, go fuck yourself. Oh my god, I just didn't add it to the visited. Okay. That makes me feel much better, because I thought I had a great idea of how to do this problem. I had like really... Nice, thank you. I would have done tries too, yeah. Actually, I don't know... Like looking back, I don't know if a try is that much better, just because like the length max is 10, but I kind of think it's better. Like a part of me thinks it's better. And hey, when in doubt, I enjoy the practice, or it's probably beneficial to practice actually creating the try. So, not that upset about it. Let me just check out my phone. This one felt really good. Like of all of them, this one did feel quite good. What was my 2024 solution? Okay, yeah, essentially it's the same thing. Go for tries even questions. Yeah. I like, probably in an interview I should like discuss it. But I feel like it's just worth it. Because implementing this try took me like 3 minutes. Like I just have it like in my head what a try is right now. So, okay, cool. I enjoyed that question. Which is crazy. I've like gotten to the point of enjoying questions. All right, let's pick a random one from here again. I should probably do course schedule again, just because like topological sort doesn't stay in my head very well. Could also do like search and rotated array. Let's try that one. Are you good with DP? Like, not really. I'm like okay at it. Like, I think if given enough time, I can typically figure it out. But if they ask me a DP question in the interview, I might fuck it up. What did I want to do? Which one? Search and rotate array. Alright, what is this one? There's an integer array num sorted in ascending order. Good luck, man. Thank you. Appreciate you stopping by. Prior to being passed to your function, nums is possibly left rotated at an unknown index k, such that the resulting array is nums k plus 1. Sure. Okay. For example, 0, 1, 2, 3, 4, 5, 6, 7 may become 4, 5, 6, 7, 0, 1, 2. Okay. So this is definitely just like a binary search. But how do we binary search? Say we start with our thing here and here. It's like if our left is greater than our right, if our left is greater than our right, where do we know the center is? We know that we can move or wait. We take like the middle of it maybe? That's like 4, 2 is 7. Is 7 greater than our right? It is. So then so we need to find target. So it's like here and here. Should just copy this to Excalibur, but it's probably gonna kill itself. Let me just go to that's not what I wanted to do. Okay. So we can say like this is our L, this is our R. So our M is U. We then can compare M to R. If M is greater than R, then we know that it's still shifted. So our L how do we like respect the shift? So something I'm thinking about is just how we move the L and R pointers. Because we need to just arrive at the target. So like say our target is 6. I know this is like a 2-pointer thing. So it's something like if M is the target, then we can just return the target. Else, how do we shift? Also, what are our loop conditions? I guess just while L is less than R. It's just like when do we move, how do we move our L and R's? Like if our L value is less than, or is greater than our R value, and our M, like what is it? I need to remind myself what a normal binary search looks like. Like if I think we just need like a two-step approach where it's like, say the num at our middle is less like if nums at mid equal target, turn mid. if nums in mid is greater than our target, so our number middle is greater than our target, typically you would want to then search the left. But it's like we gotta figure out how, like what the left looks like. I just don't have a good mental model of what this looks like. Like I can't draw it. So like, if our target is 0, then we're checking if our middle number, which is u, is our middle number greater than 0? It is. And then like, is our left pointer less than the target, less than middle? Like if nums L is less than or equal, the target is less than. But I already guaranteed that it's less than that. So if it's greater, if our target is greater than our left pointer, then we actually have to just move our left pointer to the middle, I think. Else, I think our R just becomes our mid minus 1. Does this make sense to me? So if we know our middle one is greater than our target, so say this is our target, and then we know this is greater than that. Okay, so we've fallen into this case. If this one is less than or equal to the target, that just doesn't work for this, because then our L would become here, according to my logic. So I think this actually switches. Because if this is greater than our target, but somehow to the left of our middle, we're still rotated. So else if our target is actually greater than our middle, if our target is greater than our middle, if our nums L So our middle is less than. So we can imagine our target is like say our target for this one is U. So our number at our middle would be less than, and then we check our left pointer. I just think this is all wrong, actually. Look, I'm so lost. So if it's less than our middle, typically what would happen is we want to move our right pointer in. But we need to check if our left is actually less than, then we can move our middle. So if our left is greater than it, then I think our left, oh fuck me, I'm so lost. I'm so lost. I feel like I'm so off with this. So our number is less than our target. So what if we just look at the right side instead? And it's like, is our right greater than the target? Or is our right greater than the middle? No. So our nums is greater than the target. So our nums greater than the target? No. So we need to move our right in. Is this just the same logic for both of them though? I don't fucking know, I'm so lost. I'm so lost. For real, I'm so lost. That's a good time, Alexi. Fuck my chud life. Classic binary search skeleton with low. Yeah, okay. If num's low, then the left half is sorted. If num's low, so you don't compare the target. If num's low is less than or equal to the number in the middle, okay, then you can assume that it's sorted, right? Because it's always rotated by something. If the number is low, then high is mid minus 1. Let's move low equal to mid. That makes sense, bro. Fuck me, I should have been able to figure that out. So we can just say this is left half is sorted. Then we know if num's L target is less than L equals our mid plus 1. Is that true though? No, or do we move our right pointer in? I like already forget. Yeah, it's our right pointer. It's our right pointer. It's our right pointer. Else. Becomes R. Or is it like else? Or is it just two ifs? How can we just else say like from mid? How can we just say this is else? I don't know if that makes sense in my head. So it's essentially saying like it's essentially saying here is L lower than it cool and it's sorted, but if not, like if our mid instead was this, then yeah, everything to the right is sorted. Fuck, okay. And if num's at mid is less than equal to target, it's less than equal to nums at R. So if our target is in between our middle and R, then we know that we can move our L in. Else we can move our right down. Oh, yeah. I did forget about that design pattern. No? This is something I never really understand with binary search, is like when to use less than or equal to and when to use less than. This condition is typically used when the search space LR is defined as inclusive. The loop continues as L is less than or equal to R, allowing for the check of a single range element where L equals R. Okay, so I should just like do this because this is the thing I've learned. Okay. Okay. Sorry, I'm just taking a little brain break. I don't even think anyone's here actually, so it doesn't fucking matter. Okay. Okay. What do we want to do next? I really liked this problem. Meeting rooms. I don't know if I've seen this one. I would appreciate if they did a reconstruct itinerary. At least I think I would. Would I? Oh, fuck me. I already forget this question. I know I did it like not that long ago. Because I remember vividly this is not topological sort. Because I tried to have it as topological sort. No, this is the one where you have to like reverse the list at the end. You make like a mapping of which ones can go to what. It's starting to come back to me. You like make a mapping of what destinations can go to where. And then you have some stack. And while there exists a place you can go, yeah. Yeah. Okay, I think I have the solution in my head. Fuck me, what the hell happened here? Yeah. Okay. I'll be right back. I should really make a be right back screen. What if I take a second to do that? No, probably not. Fuck it. Actually, just don't care. I don't care. Be right back. get back to it. Meeting rooms. You're given an integer n, there are n numbers numbered from 0 to n minus 1. You're given a 2D integer array of meetings where meetings at I equals start I and I means that the meeting will be held during the half closed time interval. Start I and I. Wait, what is the half closed time interval? I don't fully understand what that means. Oh, sure, okay. So, inclusive on the start, exclusive on the end. All values of start are unique. Meetings are allocated to rooms in the following manner. Each meeting will take place in an unused room with the lowest number. Okay, I should probably just type. Meeting to lowest unused room. If there are no available rooms, the meeting will be delayed until, if no rooms, then delay until 3. Delayed meeting has some duration. When a room becomes unused, meetings that have earlier original start should be given the room. So it's kind of like a queue for when a room becomes unused. Earlier time given priority. Yeah, okay. Return the number of room. The number of the room that held the most meetings. If there are multiple rooms, return the room with the lowest number. And n is the number of rooms. Okay. Is meetings sorted? Because if not, we definitely should sort them. Meetings length. And all start values are unique. So yeah, I think a good starting point is definitely just sorted. Yeah, I think it's ascending by default. Okay. So let's run through an example. Time t equals 0. Is it already guaranteed to be sorted? No. Okay. At time t equals 0, both rooms are not used. The first meeting starts in room 1, or in room 0. At time 1, only room 1 is not being used. Okay. So we'll need some dictionary of like rooms to next available time. It'll be just like a default ticked event. And then we'll need some queue for delays. Definitely need some type of queue. Um, I think this just isn't that hard. It might be just some crazy time constraints because my thinking is just like, okay, we go through the meetings. 0 is our start time. So if our start time like we can just do in the case of like if I guess we need to like iterate over each meeting, like each room number. Maybe there's a better way to do that instead of just iterate. Because like the naive one is just like you go through each meeting and then you go through each room. And if the room becomes available, maybe this is better as a heap. Because this kind of loosely, it's giving me notes of, what is that problem? Fuck, why can I not think of it? Is it bus routes that I'm thinking of? No. It's one that had, task schedule, maybe? Yeah. It reminds me of this, where it's like we have something that we can, yeah, I think it's something like this. But do I need a heap is my bigger question. Like, does this have to be a heap? Because when do you push back onto the heap? I think a heap actually is probably a bit better. But we need to negate them. So schedule is heapify. Negative start. I think. Except it's not fully like it. Because we need to... I still just don't think this really solves the issue of, like, needing to iterate over the jobs. What if we just do that? Actually, I probably still like it more as a heap. Fuck me, I can't redo it. Need to be better at, like, thinking through. Well, to run or meetings? For I just wonder if there's a better data structure for storing these times. And there probably is. So we don't have to loop through it. Probably like a min heap, actually. And we will probably need a num meetings. Something like this, right? So if there's, just don't know if I fully remember. It shouldn't be like a remember thing. It should be like an understanding thing, but I don't fully understand this. So if there's nothing to run, then we can jump our time to the thing that's waiting. But I actually don't think we can do this. I think this needs to be like I think instead of to next val, it needs to be like next eval. But I just think we would pop from here. Because I kind of don't understand why we don't pop from on cooldown. I guess because it's handled down here always. I gotta think like I don't have this on an interview. Like it is Thursday, it's 1 p.m. I can't look at a different fucking leetcode thing. Just solve it. Just fucking solve it. There's nothing to run. Else if there is something to run, or like to schedule or something like that. So there is something to schedule. Ah, fuck. I don't even know if this is like a good way of doing this, actually. Because like, how do we even decrement? Okay, I mean, I was thinking of 2 min heaps. It's probably just easier. Fuck, I'm so shit. Because you don't need to like actually care about what times these things happen at. Wait. The start doesn't make sense to me. The second heap keeps track of the end times of all the meetings that are happening. So I think this actually starts as like an empty thing. if next avail, then heap push. I'm so slow. Then heap q.heap push to run, or to running. And what do we want to push to here? We want to push end time. We want to push our end time and next avail dot top left. So now in running, what's the end time and the exit for run. Else so if there's nothing available, in the case that there's nothing available, what do? We have to wait them. So we go heap q dot heap push, and here we actually also need to keep track of let's equals 1. Else no available room. So push to the lowest, push to the like room that will end first. So heap q, we actually want end time room end equals heap q dot heap pop. That will be running. I don't really understand this, the necessary for next available. Because once it gets full, do we not just like always take the one with the closest end time? I don't know. So heap push, like because in my head, what I have to do here is end time plus end room end. But this case just like doesn't use next available at all, which doesn't make sense to me. But also I don't know how I would need it. Because I feel like just as soon as one becomes like, we don't care about the time. I just think it's fine. So room frequency, so I guess it's actually easier as end or as return actually we don't need index of. Or technically we do, even though the ith room. Let's see if this even works. I'm not gonna worry about optimizing. Huh? I don't understand. How are we ever in this case? Because we will always have a next available for like the first couple, which we then push to our running. And then once we get rid of that, then we have to have stuff in running. What? Why did it just print none? Because heap.q.heapify doesn't return anything. Haha. Fuck my life. Keep forgetting about that. Dude, I just forgotten how heap queues work. Because it's not pop left, Aiden. Let's see if I time limit exceed or something. Okay. So we would go 2 to 13, 3 to 12, 7 to 10. Ooh. Wait, no. It's because I don't account for start time, I think. I should really just look at the solution. Oh, because the lowest start time should be the one that we're pushing to. Like we push. I don't understand. I'm just stupid. Dude, Ben, I'm so fucking cooked, bro. I'm just. This is so bad. This is so bad. I'm just getting beat to shit over and over again. I should just be like doing OS. All busy. I just kind of don't understand why I can't just like... Like, I guess it makes sense. You have to release the rooms, but in my head it's like, fuck a released room, bro. Like, why can we not just like arbitrarily say, okay, now it's that time? Because that thing should be queued, essentially. These are quite difficult problems, dude. It's like, these are what I'm gonna get. Which sucks. Like, we push to running. Start time. So the lowest start time should be the one that goes first. And then we pop the lowest... because this would pop based off of the lowest start time, but it's actually, we need to pop based on the lowest end time. Is there a way to like specify which index to look at for heap pop? So probably like the most. Yeah. Alright, that makes sense then. I actually did figure it out. Okay. While running and running at 0, 0. Come on. Is this unequal to the start? Then that job is done. If next available, then our index is heap queued at heap pop of next available, and we can just heap queue at heap push to running. And index else. We will take this, but we will push to take it off of running. And plus So does this make sense to me? So if there's nothing available, then we push onto the running heap that we're gonna run the lowest index So I guess this is just like anything that's less than start's just gonna get popped. Because the time just moves arbitrarily to that point. I guess that makes sense. Like, if there's nothing available, then it's doing the same logic that I did, where it's just like, if there's nothing available, then the closest end time is what it's going to go to. Okay. Nope. Okay. Is running not a heap? I guess yeah, I could just change this to range, but that won't change anything. While running and running 0, 0 is less than or equal to start. Pop from running and push to next available. If next available, the index is popping, and we add to running and index in R. Old sweep pop to running. What? I don't understand. Also, our end time index is heap pop from our running. Oop, I understand. Yeah, that's my bad. Okay. At least that makes sense. Okay. Let's see. Actually, I mean, I quite liked that question, to be honest. With all, in the grand scheme of things, that was a nice question. And not that bad. I mean, I've done most of these now. It's just like, do I remember them? Like, not really. Because they're all so hard. Maybe I just pick a random leetcode problem. Did pro access? No. Given a 2D grid of characters, a word and a string word, return true if the word is present in the grid. Otherwise return false. For the word to be present, it must be possible to form it. For the word to be present, it must be possible to form it with a path on the board with horizontally or vertically neighboring cells. The same cell may not be used more than once. I almost feel like we just build like the most rudimentary try, which is like kind of funny, but for cat, and then you can just do like dot starts with, but you could also do something like just backtracking on the path. I think that's more the intended solution. Def backtrack. And what would we be backtracking on? We'd have some path. We would need some sort of like a visited, maybe. Look back at this. So what would we actually backtrack on? We'd have some path. We need some sort of like a visited. That maybe is like the path and the row and column or something. Like a 3D thing. Or we could do visited as like a set. Hold something like this, where it's like path, and then a row and column maybe. I really don't like that much, but whatever. Kind of don't know how else to do the same. How do we make sure this thing actually propagates? Is the path actually? Because what does this accomplish to pop after? Does the path have to be a global? What if it's something like this? C plus DC. So we try all those and then we pop. Can I do something like this? Can I or equals? Is this something I can do? I don't think I've ever done this. That's probably the stupidest way of doing this. I never add anything to my visited. I just made it for no reason. That makes sense. ChatGPT, just call me an idiot. So fucking stupid. Okay, I think I need to end. God, I'm so shit at these.